Good morning. Today we are going to see the design of double lacing. Already we have gone through design of single lacing, and now we are with design of double lacing. Problem we have kept same. This is lecture number 17, and we have in the same way designed double lacing as connecting system for built-up column with two ISMC 300 at 358 Newton per meter connected back to back. Spacing between channels is 200 mm and gauge distance we have that is 50 mm. Slenderness ratio that is given for batten column 90 and factorial axial load on column is 1100 kilonewton. Now step 1 we have as usual that is given data, and there we will be with step 1 given data. So we have given that is 2 ISMC connected back to back. We are in the same fashion that of last problem. We have given this distance that is 200 mm. And gauge distance we have given that is 50. So we have here also we have 50. Then slenderness ratio that is lambda is given 90 and factorial load we have 1100 kilonewton. 1100 kilonewton. Now we will switch over to step 2. Now we are going to draw the diagram in which we have to find value of A1. Now what is A1? We have already seen. We will go to the next slide and we will draw diagrams over there. So we have double lacing now. So try to understand the difference between single lacing and double lacing. So this is thickness of channel that is TW. Then we have 200 mm that is spacing of channels. Then again this is thickness of web, and then we have this is width of channel. Now we will go with double lacing. I will change the color for double lacing so that you will understand easily. So we have been double lacing in this fashion. So single we have, and then we have mirror image of it as double lacing. And then we have like this. So on this side also we have. And now in front of this again we have another part. In front of this we have another bolting. So we are in this fashion. So you can see these are not connected over here. Not connected. And then we are been in this fashion. And then we will go on this side. So we have this as bolt. Now in first, we have A1 that we know distance or spacing of lacing, that is distance of the individual member. So we have this channel, and that we are going to say unsupported length. Now we have bolt over here, and that gauge distance is given 50. So gauge distance means we have this till bolt. Here also we have this distance that is 50. So angle we have been 45 degree. And we have this as length of lacing. Now this distance is given from center to center bolt, that is 300 millimeters. And as angle is 45 degree, so we are going to be, that will be same. So A1 we will get it as 300 mm because angle is 45. And in last video we have committed mistake to find L. So we have actually sin 45 equal to 300 upon L. In last video single lacing we have committed that mistake. So it will be sin 45 that is equal to 600 by L. So now here 300 by L, and from this we will get value of L that is equal to length of lacing, and we will get this value that is equal to 424.26 millimeters. That is same, only change we have in A1. Now we have A1 upon R minimum that is of single channel, and we have this value that is 300 divided by 26.7. You can see this step is also same. So change where we have this change, first we have change in A1, and then we have this value 11.24, which is less than 50, which is less than 0.7 into 90. So need not require to calculate. We know this comes less than 90, and therefore okay. Or you can write same. Then we know that is transverse shear, or you can write VT. Transverse shear equal to VT equal to 2.5 upon 100 into 1100. This value also comes same 27.5 kilonewton. Now we have force in each channel. So force in each channel, we have Vt by N, and that is 27.5 by 2, and that comes 13.75 kilometers. Then we have force in each lacing, force in each lacing. As we have lacing on both sides, so we have Vt by 2n into cosec of 45. Because in last I have already explained we have this, and we are interested force in this, and therefore it will be divided by sin 45. So it comes cosec 45, and we have 13.75 upon 2 into 2 into cosec 45, and we will get this value 9.725 kilonewtons. So 73 I will say kilonewtons. Now next step we have design of lacing plant. Design of lacing plant. Now I have not mentioned clauses already. You are well known with clauses now. Then we are using 16 mm diameter bolt. Diameter bolt. So change you can see now. You have change over here. I am making circle change in single lacing and double lacing, and therefore we have width of lacing equal to 3 into 16, which is 48 millimeter, and then thickness of lacing we have thickness of lacing, and that is equal to 1 by 60 into length of lacing. Already we have calculated length of lacing, which is 1 by 60 into 424.26. It comes 7.70 millimeter. And therefore provide, so we have third change over here. And therefore provide lacing flat, equal to 50 mm by 8 mm. Now, once knowing this, we have to find its strength, and therefore we have R minimum. Now we have seen how it comes. So I will directly write now T by root 2 in exam also it is expected you can go directly. We have 8 by root 12 and we have this value 2.31 millimeter. Then find value of lambda which is equal to L upon R minimum and that is equal to. Now you can have clause in IS and that clause will say your value of lacing in case of double lacing that is length 0.7, 7.6.6.3. So we have clause number 7.6.6.3 and 0.7 into L and we have L distance between intersections 424.26 and then we will get this value 128.56 millimeters and sorry this is only L we are mentioning. So I can write R minimum below it, which is 2.31. This is also 2.31. And then we have this value 128.56. Now, as we know, it has a flat and therefore we have buckling class C for it, same as in last, buckling class C. Now we have actually 0.7. So this L effective is 0.7 L. This will be our fourth change in single and double lacing. Then we have KL upon R. So KL upon R, which is for 70, and KL upon R, sorry, not for 70. So we have for 120 and for 130. And 120, we have this value that is equal to 83.7. And for 130, we have this value 74.3. And from this, we will find value of FCD equal to 74.3 plus 83.7 minus 74.3 divided by 10. We have taken reference that is of 130. So 130 minus 128.56 gives me value of FCD that is equal to 75.65 Newton per mm square. And from this, I will find value of PD, which is equal to AE into FCD. AE I have 50 into 8. FCD I have 75.65 gives me value as 30.26 into 10 raised to 3 newtons, which is equal to 30.26 kilonewton, which is greater than 9.725 kilometers. So likewise, we have to go that is for double lacing. Now, next part we have that is connection. I will not repeat the part which is below it. We have in the same fashion, we have to find value of VDB and then from N number of bolts equal to 9.725 upon VDB. This comes less than 1 and therefore we can say provide 1 bolt. Now, while going for VDPB, that is, we have to find two VDSB and VDPB. In this, we have to consider KB1 because we do not have any pitch, we do not have any end distance. And then we can assume this as KB equal to 1. And we have actually lesser value that is of VDSB because we have this as single shear. And likewise, we have to go for double lacing. Single already we have seen. So now we will stop here only. So thank you.